Hi, everyone. Great to see you at our 10th Data Quality Meetup. We are going to give folks a few more minutes to join. And in our usual tradition, while we are waiting for everyone, let's use the chat on the right to type in, where are you calling from today? And if you have done a migration, what was that migration from and to? So I'm in Estes Park, Colorado today, and I am one of those folks who migrated Redshift to a Hive data lake. If you're not migrating right now, that's okay as well. I think there's a lot to learn for future and past projects and handling large data projects in general. Looks like a lot of folks are migrating out of Redshift. Seems like a pretty big trend right now. That's fun. Well, yeah, SQL Server, of course. Cool. So if you don't know me, my name is Gleb Mezhanskiy. I'm CEO and co-founder of Datafold. Before Datafold, I spent pretty much my entire career doing data engineering at companies including Autodesk, Lyft, and Phantom Auto. Very different companies, very different company stages, from a very established public company all the way to a seed stage startup. And it just so happened that I got to build data platforms and do quite a bit of migrations throughout my career, most notably at Lyft. And the topic of data migrations is just near and dear to my heart. So really, really excited to dig in today with you all and, of course, our awesome speakers and panelists. So to set some stage for the discussion, I think, first of all, it's important to just set context of what do we mean by migrations. So I think it's helpful to probably come up with two main types of migrations. One is when we are moving our workloads from an old data warehousing system into a new data warehousing system. For example, we used to run analytics on Oracle, and now we're moving that all to Snowflake. So both data and workloads. And another type of migration could be keeping the same warehouse, but changing the data transformation framework that we're using. For example, we used to do transformations in MicroStrategy, and now we're adopting a new framework such as dbt. A lot of the times we would do migration of both the warehouse and the transformation framework at the same time. And it's also, I think, helpful to say what migration is not for the context of this discussion. It's different from data replication, right? So when we are continuously syncing data from, let's say, MySQL to Snowflake, so we can operationalize this data in the warehouse, that is, in many ways, a similar pattern to migrations, but we're not intending to turn off MySQL in this case, right? So this is somewhat different use case, although some of the tools and challenges that we will probably be covering today are quite relevant for that as well. But for the purpose of today's discussion, we're going to be focusing on really moving our workloads and code bases and data from old systems to another, or potentially refactoring, doing major refactorings in our existing code bases. So why do you even talk about migrations? I think that everyone who has done a migration in their journey in analytics knows that migrations are usually very complex projects. They're not fun. They don't feel like productive work because we're not really creating new applications for our stakeholders. They run over budget and over timelines, never complete on time, but we're still doing them because they are necessary. So when a data team realizes that they have to do migration, that's probably because their old systems or their old code base or their old patterns are no longer aligned with the needs of the business. So it is a very important topic for us to discuss. So today, we are going to be joined by 4 amazing speakers, all data leaders, hands-on data practitioners from different companies and different roles. And we'll hear 5 lightning talks, so 4 from the speakers, and then I will conclude with a short lightning talk about my own experiences doing migrations. And then we will transition to a panel discussion where we will dig deeper into some of the topics that the speakers brought up today, and talk about some of the common strategies and common pitfalls and do's and don'ts that come from our shared experiences. So without further ado, I would like to invite on stage Saurav Ganguli from Fitogram. Fitogram is Europe's largest fitness and sports aggregator, offering individual sports membership as well as corporate fitness plans to companies of all sizes. And Saurav is a data and machine learning engineer there. So welcome on stage, Saurav, and please take it away.
Thanks, Gleb. Yeah, let me start to present my screen. All right. Hello, everyone. I am Saurav Ganguli, based in Germany, working as a data and machine learning engineer at Fitogram, which is part of the Urban Sports Group. So today I will talk about our new data platform, which we recently migrated from Postgres to BigQuery. To say a few words about the organization, Urban Sports Club is Europe's largest sports and fitness aggregator, offering sports memberships as well as corporate fitness plans to companies of all sizes, over 50 sports through our network of more than 10,000 partners across 8 countries in Europe in over 100 cities. To talk a bit about our team structure, we have a distributed model with data teams across 3 different departments. There are 9 data analysts spread across the 3 analytics teams: product analytics, business analytics, and marketing analytics. We have 3 data engineers solely in the data platform team that are responsible for the data infrastructure of all the teams. To give an idea of what we had, here's our old data infrastructure, with Postgres being the data storage solution and Metabase being used for reporting. This slide shows the current data infrastructure, with BigQuery replacing Postgres and Looker being our new reporting tool. We now have access to real-time data ingestion and a new machine learning platform to support ML ops. To give some context into why we switched, the old data warehouse being Postgres, which is more of a transactional database than an analytical database, was slow to develop and run. This was further driven by the avoidance of off-the-shelf cloud products and open source tooling. Further, the reliance on a lot of custom code made development extremely slow. Resetting the strategy meant removing a significant chunk of the development time and cost whilst improving our delivery roadmap. Aligning with the company tech strategy meant shifting to GCP. This also enabled us to leverage modern data stack, which speeds up development, enables us to manage our data transformations, and incorporate better data governance, observability, and more secure connections. Now coming to the most important section of how we managed to do it. The migration could be broken down into 4 phases. During the assessment phase, we created our roadmap, aligning across people by creating a centralized data platform team, consolidating the different data engineering teams within the organization, and bring people who had knowledge of the new tech stack that was previously adopted by their teams. For our technology alignment, we focused on vendor-first solutions and GCP-managed architecture. For the data distribution planning, we researched on the best industry practices and leveraged existing resources to inform our approach. The final decision was to construct a schema layer architecture where data ingested from the source undergoes varying levels of transformations, and the end models in the reporting layer are used externally to connect to Looker. Finally, for our process alignment, we identified the core schemas for the migration prototype, which add the most value to be tackled with utmost priority to deliver within a short span of time. What helped us in this process was to employ external consulting who could assess our roadmap was the right choice. Also, some best practices from our previous roles helped us make informed decision on the choice of tooling and architecture. Where we were not sure, we spent some time evaluating multiple tools and models and then picked the one which suits us the best. This led to the creation of a solid foundation and decision documents which the different teams were confident of. During our migration, as decided, we did not move datasets and tables from our old data warehouse to the new one. Instead, we plugged all our sources to the new data warehouse, majorly using stitch ingestion tool, and built our refactored data models from the scratch. However, through our development course, we realized that there were some tables which still had to be migrated. This was because of several reasons, such as the source being deleted or data in the source getting corrupted. In these cases, the only real backup was the ingested table in our old data warehouse. For these one-time ingestions, we tried to manually move tables by extracting them as CSV files and loading them into the BigQuery tables. This worked fine for smaller tables, but could not handle for the heavier tables. For these heavy tables, we then went ahead with connecting the old data warehouse to Stitch and loading the tables into BigQuery. The one major problem we have with using data ingestion tools is that we have no control over the ingestion process, which causes breakages due to schema changes and incorrect data formats. Because these issues only occur rarely for now, we are manually handling such changes. We are manually handling such changes when the schema changes occur. But going forward, we plan to set up testing in the source data to detect the changes and notify us at the beginning, empowering us to act before it causes breakages in the production pipelines. However, using ingestion tools helped us to run our data ingestions independent of our main pipeline executions, which caused reduced runtime complexity and reducing the execution time by almost 2 hours daily. Once we had plugged all the required sources using new and existing tools, we were ready to move on to the next phase. As decided during planning, we did not migrate everything at once, but started small. Our data is mainly divided across three domains: members, partners, and corporate. Since member data is our most valuable asset, we decided to move this first and build on our experience to migrate everything else later. We then decided to leverage dbt for all our data transformations. This was due to previous experience with dbt. We identified it as the best approach owing to the ease of creating data transformations for analysts without having to write complex SQL queries and Python code to run the data models. To begin with, we created a dbt project as per the layered approach. After the first source was connected and ready to start writing our data transformations, going forward, we built our source connections and transformations in parallel by having engineers create these connections that analysts could immediately start to transform. A big concern in the old data warehouse was that we were never able to employ proper data monitoring. And this time, we wanted to track data quality right from the start in both source and transform data. But since we spent a significant amount of time in this phase, it meant we also had to keep the old data warehouse alive until we were completely ready to roll out the new data platform. To speed up development for the new data warehouse, we decided that no new development will happen in the old data warehouse except for bug fixes and critical changes. We also assigned engineer of the week so that one person can focus on the issues and the other team members are able to work on the development. Using our approach, we were able to have accelerated development time. In some cases, what would take well over a month earlier could be achieved in a week now. Further, using our incremental delivery methodology, we were able to publish the first data assets in about 6 months with around 52% migration completion status. Finally, the creation and deployment of our infrastructure was mostly done using off-the-shelf and open source tools. We have Cloud Composer for scheduling our workflows, which compared to self-hosted Airflow that we previously had, this being Google managed is less maintenance and takes care of automatic scalability. dbt docs allowed us to have data observability and by providing lineage graphs and dependency between models, while dbt tests provided us a way to write simple tests from the start. Our previous reporting tool Metabase was sluggish and unusable as a data product. Switching to Looker for reporting and visualization made it much quicker and simpler for other teams. We used infrastructure as code using Terraform to deploy our infrastructure in order to better observe and manage the changes. Although Cloud Composer is easy to manage and deploy with autopilot, we have less flexibility with managing the configurations. We started with the smallest composer and soon discovered it would run out of memory when running heavy jobs. We then decided to use Kubernetes pod operators to run the heavy jobs, which allowed us to still have a small composer but spin up a Kubernetes cluster on demand with higher resources and stop it when not in use. Despite using off-the-shelf and cloud-managed products, we were able to achieve little to no higher costs compared to our previous infrastructure. There has been drastic changes in terms of pipeline execution speed, which would earlier take up to 8 hours, now being executed in less than an hour. On top of that, we are now able to publish daily run and test reports. What's next in our roadmap is to build a data mesh architecture for data democratization, have real-time or near real-time data ingestion using PubSub and Cloud Functions, having a data catalog solution for better governance, as well as a platform to run ML ops. In addition to creating an experimentation platform using A/B testing for better analytics and creating data products to unlock new revenue streams. All of this allows us to have more actionable data that ultimately improves the processes for all data stakeholders. That's the end of my presentation. Thank you all for listening.
Thanks a lot, Saurav. Sounds like a really well-managed and efficient migration project. Feels like a breath of fresh air relative to my personal experience, and really excited about your upcoming roadmap. Also, thanks for sharing your kind of like existing architecture for post-migration. It looks like you really up-leveled your BI tools and also the transformations with dbt, and have like a really good governance projects for change management. So really, really exciting.
Thank you so much.
Awesome. Next, I'd like to invite on stage my long friend and data partner, Maura from Two Chairs. I have known Maura for quite some time, probably starting when she was running analytics and data science at Patreon. And she actually participated in at least a few data quality meetups before that, when she was at Patreon. And now Maura is head of data at Two Chairs. And Two Chairs is a virtual mental health platform that strives to match clients with the right therapist by considering each client's needs, goals, symptoms, and preferences to identify therapists with ideal background, style, and areas of expertise. Definitely a great cause that I can only imagine how data is important here. So, Maura, please take it away.
Awesome, thanks, Gleb. Excited to be here and talk a little bit about a case study from my time at Patreon. So quick background, I think Gleb gave most of it, but right now I lead data science and data engineering at Two Chairs, really early stage data team of 4 people, and an interesting focus for the team. We sort of do half research and inference on therapy outcomes, and then half sort of normal product and operations analytics to help the company scale. Before that, I led data science and data engineering at Patreon, where I grew a 25-person centralized data science team and got to see all stages of data maturity, from 1-person data science team all the way up to 25. And before that, I was at Google focused on trust and safety data science. When I thought about data migrations I could speak about today, I have like many battle wounds from data migrations in the past. First migration ever was from cron to Airflow. Currently undergoing a migration from stored procedures to Dataform, which is like Google's version of dbt. Also did a big MySQL to Redshift migration. And then I think there are also migrations that maybe fall outside of those classic database migrations, like tooling migrations, moving the notebooks that a team uses, or engineering migrations. What if the engineering team moves a major backend system and it trickles down to a lot of changes for the data science and data engineering team? But I thought I'd talk about instead a migration that really affected end stakeholders, because I think often migrating a database, your other teams in the business shouldn't really know that it happened, other than having maybe happier data scientists who are using Snowflake instead of Redshift, and happier data engineers. We did a migration at Patreon of our entire metric system from cash-based to amortized accounting, and it really affected the whole business. So I thought it would be an interesting use case to talk about. To get a little bit accounting nerd for a second, and apologies to any accountants in the room, we needed to move our entire way of calculating money at Patreon from cash basis, which means when you get the money, you record it and say it was paid, to amortized, where you spread out that money over the entire course of when the payment and the service is rendered. We were doing this because we were greatly maturing our accounting practices in preparation, really to be IPO ready and to be kind of a mature company. And we also were launching annual memberships at Patreon. And for context, Patreon's a membership platform for creators. So when you move to monthly to annual memberships, suddenly that service is rendered across the entire year. And so all of your accounting and metric systems need to reflect that, to really be in compliance with what you should do from an accounting basis. A little bit of context on sort of the stack we were working on the time. We were using Airflow to transform data, landing that data in our data warehouse, which was Redshift, and then visualizing a lot of that in Mode. So the context here, previously, if we got a $20 monthly payment in, say, January, we'd say, great, we got $20 in January. And if the leadership team asked, how much money do we have Patreon, we'd say $20, and like, we're all good to go. Then we launch annual payments. So let's say we got a $20 monthly payment and then a $60 annual payment, both in January. Well, the data engineering team, we were like, got it. Okay, $60 divided over 12 months, 60 divided by 12 is 5. We just will say we get $5 every month, and we're kind of good to go. But turns out this is actually incorrect, because for amortized accounting, you need to spread that payment out over all of the days in which it occurs. So instead of dividing by 12 months, you need to divide by 365 days. And because months have different number of days, suddenly you have a $5.09 payment in January, and then a $4.60 payment in February, and $5.09 again in March. And it gets pretty complex. And if you're just trying to understand the total amount of money in a given month, that's pretty easy. But if you're trying to answer questions at the business like, how many members do we have paying $5 payments? Suddenly it gets more complex, because we never had decimals in our system before this launch, and we never had future payments. And so it kind of made our brains melt a little bit to how we were going to move this entire system and migrate over to an entirely new way of understanding money at the business. So why was this so difficult? We had built our data model, our data warehouse, all of our translation and transformation layers around core assumptions for 5 years. Those assumptions being that payments were monthly instead of daily, that you couldn't have payments in the future. So suddenly now we had future money at the business, and we had built all of our data models around the fact that payments all happened in the past. And suddenly we had decimals instead of whole numbers in our system. This also required really complex downstream BI engineering. If suddenly all of your tables in your warehouse have future data in them, and you've built all your dashboards with x-axes that have months, suddenly you're going to show many, many months into the future with tiny little payments that you've accrued in the future. That's going to be very confusing for stakeholders. The third, it was a huge cultural shift in the way we talked about the business. Imagine trying to get 400 people to understand amortization logic, which is this like pretty obscure accounting idea. That was a lot of work to change the culture around it. And finally, this was tied to a big product launch. Annual memberships had been something creators wanted for a while on Patreon. There was a lot of visibility and pressure for us to understand this launch rigorously and accurately. And so we needed to make sure this migration, again, of the entire way that we understood payments at the business was going to be accurate. So our approach, the first, I think, with any migration, and again, this is kind of a different kind of migration because it really affected downstream stakeholders, was to get crystal clear on the requirements. I don't know if any other people in this room have ever tried to get accounting people and data engineers to talk to each other, but we don't exactly speak the same language. So there were like a lot of conversations with accounting around, okay, this is what your logic says. If we write it into the Airflow DAG in this way, is that going to be accurate? The second was to think deeply about like where in the data architecture we were going to build in amortization. Should it live in one place, or would we be okay having this really complex logic in a few different areas? What layer of abstraction within our data architecture should it live at? Should it live in base tables that we ask engineering to create for us? Should we build it into an Airflow DAG? Should it just live in the mode queries and the end dashboards? And who can make changes to it, and what does that require? If a data engineer wants to go in and update the logic, say, for example, because we launch a new currency and we need to make sure that currency is accurately amortized, what kind of approvals do they need, given that this is a metric that we're reporting, to investors, to the business, and ultimately is one of the most important metrics of the company. And finally, really defining what was needed for a hard launch date, and then the long tail of updates for when it would actually be done. And ultimately, we did decide to build this into one very complex Airflow DAG and let everything flow downstream from it, just again to really have control over the migration in one place. And I think what's interesting about this kind of migration is it really touched across the people, process, data, and tech. Again, people, every single stakeholder that was using dollars at the business, which is essentially everyone, since all of our core metrics are about money at Patreon, was going to need to understand this change and use dashboards that would be impacted by it. On the process side, a lot of our things like monthly business reviews or the way that we reported metrics would need to change to reflect this. Of course, on the data side, our data engineering, all of our tables had to change and be updated for amortization. And then the tech side, we did look at new tools to make this migration easier and more confident. And this was actually the motivation for us starting to adopt Datafold, because we wanted to have data quality and really have assurance that the changes we were making were accurate. So a few lessons learned in memes. One is that data culture and metric change requires a lot of handholding. We would go to our business teams and be like, hey, there is no cache-based version of our metrics anymore. We are in a new world. We have migrated off of it. And they'd be like, yeah, I got it. And then they'd be like, but I can still use that dashboard I had from 5 years ago, right? And we'd be like, no, you have to use this new version. And so just learning, you can't toss a new thing over the wall to stakeholders. And I think this is true as well when you do migrate backend systems. If you're migrating Redshift to Snowflake, you can't just tell your data science team one day, hey, here's Snowflake. You really have to handhold into using the new thing, educating around it, all of that. The second is that sometimes you need to rip off the Band-Aid. I think in many migrations I've led, there's this challenge between slowly migrating the thing over 6 months and taking 10% of the team's time every week versus ripping off the Band-Aid and sort of risking stakeholder wrath because there's so much change at once. And what I've learned is that sometimes you really need to rip off the Band-Aid to preserve the team's time and focus. If we had done this over the course of 6 months, it would have been really slow and painful. And every week when we go back to it, we'd have to gain context again of what we were doing and why we were doing it. So instead, we did a really focused sprint. And that was painful for stakeholders because all their dashboards changed overnight. But it was, again, helped the team preserve focus. And finally, I think tools can help build confidence, especially on the data eng side, but end user testing can be really hard with data workflows. As mentioned, we did adopt Datafold to help us with this change, build confidence that, in the cache-based system, if we said we had $4 million last month and we migrate it to amortized, we should still have exactly $4 million. And because of decimals, rounding errors get introduced and it can get really complex. So again, we wanted some diffs to know that the actual underlying data was accurate. But when you have stakeholders across the business using hundreds of dashboards that are impacted by a migration, sometimes what you need to do is go up to your accounting team and be like, hey, does that dashboard you use every day feel and look the same to you? Do you feel like it's accurate? Business stakeholders have a really good sniff test for when the data is off. And so even though we built a lot of confidence in the underlying data model, we still had to do a lot of partnership with stakeholders to make sure that they felt confident that the data was accurate. And ultimately, this is about building data trust. You can tell your stakeholders, yep, we know the underlying table is accurate, but they're really only going to trust it, again, if it passes their own sniff test. So those were a few lessons from my time migrating Buddy. Thanks everyone for listening. I'm excited to chat more on the panel.
Thank you so much, Maura. What a great story. Also sounds like a great success story with how you navigated a really complex change of business logic with a lot of stakeholders, starting from engineers to also business users. That's really, really impressive and inspiring. And also just speaks to how at times the work that data teams are doing is underappreciated, because on paper, even in terms of accounting, that sounds like, yep, we're just transitioning to a different methodology. But what it takes in terms of actually changing the business logic and updating dozens or hundreds of dashboards for stakeholders, that's massive amounts of work. So thank you so much for sharing. Awesome. So our next speaker is Drew Beaupre from Mammoth Growth. Drew is CTO of Mammoth, and Mammoth Growth is a consultancy that offers growth marketing analytics as a service. So Drew, please take it away.
Thanks, Gleb. My name is Drew Beaupre. Beaupre means beautiful prairie in French. That's a very complicated last name to pronounce. I've heard every permutation of it. Today, I'm going to talk about how Mammoth Growth has helped many of our clients make the jumps from legacy platforms to platforms such as dbt. At Mammoth, we're a small, efficient team who's worked with an incredible number of clients. We're very tools agnostic and have worked and continue to work with just about every tool in the market. We're able to do this without being too broad because we really focus on core principles. And so today I'm going to be rapidly going through some of my thoughts around migrating from to dbt from a legacy system. At Mammoth Growth, we've done this many times over the last 4 years. And when we start a migration project, we're usually at a big disadvantage because no matter how much prep work we do in our sales process, there's always countless things which surprise us. Because of that, we're very meticulous about planning up front. We have countless war stories of which don't have any time to go through, but the most fun was uncovering a user table with more rows than all humans who have ever existed. The most important thing to take away from today is that platform migrations are hard, and you need to have a real plan for success. Start out by setting your goals, and not just what done is, but what done is. You have to have a very clear picture of this. You need to think about what your migration strategy is, and we'll go over a few today. And then finally, how are you going to think about consistency? You're setting yourself up for failure if you fail to gain your stakeholders' confidence at launch. If you take too long, you'll lose your audience. But if you have too many changes in the reports, no one will trust the data, even if they didn't trust the old system. So we're going to talk about some of our goals when we're trying to migrate. And it really starts with defining what our success is. What does the end state look like? Be really mindful of the scope of the project. This can get out of control very quickly. You'll know you're on the right track by really defining what the end state is going to look like. And you can set your success criteria based on how much variance your stakeholders will tolerate. If there are reports that your CEO or CFO are looking at, they probably shared those numbers with their investors. Those can't change. The smaller the tolerance, the more care you have to take when you're thinking about your scope. So then you can think about what not to migrate. You don't have to do it all. Do you really need to convert all of those years of tech debt? And you can start by triaging based on what dashboards are actually being used by running reports on dashboard usage, but most importantly, get the stakeholder buy-in that some of the reports will no longer be supported. Set your timeline by setting expectations. Don't start what you can't finish. And you can map out that timeline with milestones, and that allows you to make smarter decisions mid-project. Things will be very apparent when the project timeline, the project budget are out of whack. And finally, do as much upfront work as you can to limit the scope of the project. So what are some strategies in order to actually do the migration? So when we're thinking about the actual data modeling between the actual data and your dashboards. And we have 3 different options here. They're not all the options, and there's probably some space in between. The first one we call lift and shift. It's where it's the simplest of the 3, where you're just taking your horrible 900-line SQL statement and bang, you're in dbt. But it's not as crazy as it sounds, because often the faster you can move your stakeholders over to the new platform, the better. It means you can deprecate the old one and then plan on spending the next year refactoring. You can create a compatibility layer, assuming you're not changing your dashboards. You want your dashboard to remain as is. Well, you can go and do something similar to lift and shift, where you're setting yourself up for a much simpler migration on your dashboard side. But unlike lift and shift, you're going to spend a lot more time up front defining the right architecture. And there's probably some Goldilocks zone in between. The last one is we just nuke it all. We start from scratch, and you can spin this with your stakeholders, call it a greenfield project. And this is really appropriate when your old platform is kind of hopeless. There's just no easy way to really move any of that. But it's hard to get stakeholder buy-in on this because everyone thinks that there's some kind of value in all those years that you've invested in your old platform. But in the end, you end up with a clean architecture because usually you start much smaller, and it's simpler because there's less there. And unless you are redoing all of your dashboards, this option might be realistic. So theory will only take us so far. So here's a case study that we did recently where we had a client who was launching a new direct-to-consumer streaming app to replace their old app. Their legacy BI platform would have been completely overhauled, and the complexity was just way too hard. Classic 1,000. You can see here. This is an actual screenshot. Those are 1,000 line SQL statements with 20 deep nested case statements. It was just insane. There's no way that we're ever going to be able to migrate this. But we did our due diligence, and we really brought our stakeholders along, explained to them why we had to start from scratch, and ultimately we were able to choose the right tools for the right job. And so we didn't call it scorched earth. We rebranded it, called it a greenfield project, fresh approach, and this enabled us to really choose the best tools for the solution in with modern services. And so we still had a really good grasp of the requirements because we had all the old dashboards, and we could use that to really back into what the client needs were, and specifically really thinking about what do they need for launch. Ultimately, it's a pretty simple architecture where we're thinking about services to bring into Snowflake, leveraging dbt to do the data modeling and orchestration, and ultimately creating views to power their Tableau dashboards. Now, we didn't have to do all of this, and we didn't do all of it out of the gate. This was a future roadmap where we could actually map out ultimately what the larger solution looks like, but then only pick and choose the things we needed for launch. And ultimately, we, that solution really paid off because we're able to have active dashboards at launch so that the client really had visibility into the performance of their app. We also made sure that sunsetting the old platform was part of this scope. We turned it off. We archived the historical data just in case. Whether we actually ever use that data is questionable, but at least it put the stakeholders' mind at ease that we had access to that data and they weren't losing anything. Now, I hope I haven't scared you away from attempting the platform migration. It can bring incredible value to your business, provided you understand what you're getting into and you're willing to make that investment. But a smaller, leaner warehouse in the end will provide more value to the company because it enables faster, smarter iterations. Your team will be able to keep up with the pace of the product, and that is worth investing in. Thank you.
Awesome. Thanks, Drew. Yeah, I find the lift and shift versus re-architect dilemma probably one of the hardest when you do migration, because for data practitioners, it's really tempting to start refactoring some of this huge code debt, but that there's a lot of risk in it.
Yeah.
Awesome. Great. So next lightning talk is from Rafay Aleem from Faire. Rafay is a data machine learning engineer, and Faire is an online wholesale marketplace that helps businesses procure goods from millions of independent retailers. And they have a huge data platform, and I'm sure Rafay will share very interesting insights about their migration project. So take it away, Rafay.
Thanks, Gleb. Hello, everyone. I am Rafay, currently working as a data engineer at Faire, based out of Toronto. Before Faire, I had previously worked at PointClickCare, Shopify, and OLX Classifieds. I was the second data engineer to join Faire in 2020, and we have come a long way since then. Our data infra team currently comprises of 5 AEs, 8 data engineers, and 5 machine learning engineers. The team operates as a hybrid embed model in the sense that they would partner with other teams on certain projects. This can be sub-teams within data infra, product teams, and the platform teams. A little bit about Faire. Faire is a marketplace that independent retailers use to discover, source, and sell unique products from and around the world. The company was founded in 2017 and has grown into one of the major B2B marketplaces. Our current data infrastructure is based on Airflow as our data orchestration layer and Snowflake as our current data warehouse. We also leverage a lot of AWS services such as S3 Batch, SageMaker, and Kinesis. In this presentation, I will be mainly talking about how we managed to migrate from Redshift to Snowflake. So data migrations are extremely tough and cumbersome, as some of you might already know here. So why go that route? Well, in our case, we had a lot of scaling pains with Redshift, and we could not justify the maintenance overhead that came with it as the organization grew. Back in 2020-21, Redshift had coupled compute and storage architecture, and scaling and maintaining it was tricky and sometimes even dangerous. Also, at that time, Redshift only supported serializable isolation level, which proved problematic for our setup. You can read up more about that in our blog post that I will link in the end of this presentation. So eventually, after multiple considerations, we decided to migrate to Snowflake. And we just swapped out the warehouse, which should have been pretty easy, right? Well, not so much. For us, all this came with a lot of challenges since we had terabytes of source data constantly flowing into the system and being transformed into a huge network of tables. Hundreds of mode reports and machine learning models running thousands of queries daily. All these pieces need to be moved onto the new system with no downtime or data loss. We didn't realize at that time that this would end up being a year-long journey to pull off. And I would expand more on how we mitigated some of these challenges during the migration. So when you are thinking about large data migration projects, it is important to think about how to compartmentalize and divide this, because that would allow you to manage your milestones and timelines, be able to delegate work to other teams, and potentially parallelize some work. An easier way to divide and conquer here is to first understand the flow of data into and out of your data warehouse, and then try to understand the pieces that may be independent of each other. Again, migrating a live data warehouse is a highly complex task, but if I were to summarize it in our context, I would divide it into sort of like 3 grand themes. The first one is start ingesting your source tables into the new warehouse, starting from a cutoff date, and also load historical data prior to the cutoff date. Second, copy over all ETL tables and keep them updated in parallel. If there are differences between new and old warehouse, such as SQL dialect, try to wrap them into frameworks and make them transparent to end users. And lastly, have an automated data validation framework that can check data parity between tables in different warehouses. And I want to emphasize here that when you have thousands of tables to migrate and you cannot afford long periods of code freeze, there's no better way than to automate data validation on some regular cadence. So starting with the source table migration, it has become fairly easy these days due to great tools such as Fivetran and Airbyte. However, in data migration context, it becomes tricky when connector versions are updated or you decide to change vendors. To shield ourselves with this feature problem, we introduced the concept of a transformation layer in our Snowflake warehouse. This was a fundamental design change from how we had been doing things in Redshift and was paramount in enabling the migration and several of our future use cases. As you can see in the illustration, it is a logical separation between what we call raw and analytics database layers and comprises of Airflow operators and staging DAGs to maintain transformations. When it comes to controlling behaviors of external tools, there is usually little you can do. During the migration process, we actually encountered several such use cases. For example, it's not uncommon for source table columns to get renamed over the course of their lifecycle or have incompatible data types. So what do you do in this case? Migrate all downstream queries to reference new columns or cast to correct types, or just simply make the change in the transformation layer and keep things transparent to downstream as if nothing ever changed? We have found this to be a very powerful concept that enables so many possibilities with the least amount of friction on downstream ETLs. For migration purposes, we maintain two parallel branches: the main branch for Redshift Airflow cluster and a Snowflake branch for Snowflake. We use automations to keep the second branch up to date with the main branch. The process would also take care of replacing Redshift Airflow operators with Snowflake ones. This wouldn't require changing SQL from the main branch, since our underlying parser would do the translation at execution time. Finally, we use the self-serve YAML-based automated framework on top of Datafold to surface data parity numbers to our stakeholders, as you can see in this screenshot. A big shout out to Datafold folks here who helped us quite a bit during this process. I cannot emphasize enough the benefits of having a transformation layer between your raw and analytics databases. If you have one, that is great. If you don't, I highly recommend to revisit this work for the future maintainability and pluggability of your data warehouse. If you use Airflow for data orchestration, build task-specific operators for your stakeholders to ensure consistency, maintainability, and auditing. This also discourages anti-patterns such as using user-defined date columns instead of an org-wide one that ensures future consistency, such as backfilling on date partition snapshots. As much as data migrations are technical, it serves your teams very well if you can automate and make self-serve process. This also ensures you are able to get help where possible by crowdsourcing some work. If you are planning a data warehouse migration, ensure that your entire company is on board and not just your data org. It is a very complex multi-team collaborative effort that takes quite long, around 10 months in our case. So teams that work with data should incorporate related work in their OKRs. If anyone wants to learn more about our data migration, there's a very detailed blog post on the Faire crowd blog, which I think you all would really enjoy. And yeah, that's all from me, and thanks so much for listening.
Thanks so much, Rafay. I saw you mentioned that you had a SQL parser for ETL transformations. Is that something that you built internally to help translate the Redshift SQL into Snowflake SQL?
Yeah, that is correct. That was, we basically incorporated that parser into the new Snowflake operators, which would take in the Redshift SQL and just like transparently translate the data types into Snowflake types. So like the end user would never have to rewrite the SQL. And once we did eventually, like once we were out of that migration phase, we eventually translated all of that into Snowflake SQL. But during the migration process, like that was how we reduced the friction.
Oh, that's a really cool trick. And you build this internally, right?
Yeah, there's actually a repository for that, and we have it shared, like it's open source.
Oh, very cool. I think it'd be cool if you share, because I know that this is also one of the friction points for migration, one of the things that folks are often looking to automate. Awesome. So I will conclude our series of lightning talks with sharing some of my scar tissue from running a migration. And this is really a reflection on 2.5 years that I spent on the migration project that was targeted at also moving the Lyft's data platform out of Redshift into a more scalable infrastructure. And I should preface this that unlike most speakers here, I consider that I failed at this project. I don't think I did a good job, and I made a ton of really bad mistakes as kind of the main architect behind the project. And so this is mostly coming from negative experience, but definitely I learned a lot of it, and I hope that you will take some takeaways from this. So in terms of the scope, we started this project in 2016. Lyft at the time was extremely high growth company, scaling from about 600 people to quickly surpass over 1,000 in the next year. We had over 200 various data roles in the midst of the migration. So data engineers, data scientists, data analysts. we had over 500 tables in our Redshift cluster, which by modern standards, especially for folks using dbt, sounds like, well, it's not too much. We may have like over 1,000, but keep in mind this was a different infrastructure, and at the time, even that complexity was already very high. We had over 100 dashboards, Looker dashboards that were stakeholder facing and had SLAs attached to them. And we had over 10,000 ad hoc reports, primarily in tools like Mode or Jupyter notebooks. So fairly large complexity overall that we had to deal with. And the reason why we decided to migrate out of Redshift, similar to a lot of stories shared today, was poor scalability. So we had times where data team would basically take off at 10 a.m. and just go get boba, because Redshift was working through such a big backlog of queries that it was just not operational for a few hours. So it was necessary to migrate from a system that had coupled storage and compute to a more scalable infrastructure. And the choice that the team made at the time was to migrate to a data lake where would store all data on S3, and then it would have Hive Metastore and Hive processing engine on top of it. And I'm sure that there are some folks here who haven't heard about Hive, and I assure you this is for the better. Hive currently is definitely legacy technology. At the time we were doing the migration, it was kind of already surpassing its cycle and going into the legacy mode, but it was still chosen because it provided the solid open source foundation for a data lake. And in addition to Hive, there were also plans to bring in Presto for the ad hoc query execution and Spark for more sophisticated and heavy data transformation workflows. So what are the 5 things that I took away as really important dimensions to think about when you're running a migration? So tech choices, architecture, outsourcing, sequencing, and automation. And we'll cover them one by one. So tech choices, obviously, we probably can have its own meetup dedicated to how you choose a proper tech for your data platform. But specifically in the context of migration, we all know that migration has a really high cost associated to it. So when we are embarking on such a project, we have to be really sure that the tech we're choosing to migrate to is really able to support the needs of organization in the long run, at least for the next 5, ideally 10 years. So scalability is definitely an important one. User experience, so how productive the team is going to be with the new tech. Interoperability, so are we choosing a closed source system that we may have a vendor lock-in, and other systems that we may build in the future may not be able to work with it as easily. Tech trajectory, so are we adopting a technology which is sort of a mainstream go-to choice? Is it leading edge, maybe too early, or is it already going to be legacy? Cost and the open source trap. So in terms of how it panned out for us at Lyft, scalability was good because we decoupled storage and compute. Data lake architectures are inherently very scalable. User experience was where we definitely didn't hit the mark. So if you ever worked with Hive, you probably know what I'm talking about. If you haven't worked with Hive, just to give you perspective, the experience of data engineers working with it included things like it took 90 seconds for your SQL query to compile just before the actual computation starts. So what that meant is if you forget a comma in your SQL statement, or you forget to close your case when statement properly, you wait for about minute and a half, 2 minutes, just for the engine to return back this error. And that may not sound as much, but if you're doing rapid iterations during migration, that really kills the productivity and really makes the whole process extremely slow. There were other things that were bad for Hive, but that is a discussion I'll have with you over a beer in the bar if you ask me. Interoperability was great because, again, data like architecture, our data was stored in Parquet files, could be queried and used by multiple systems, including Presto and Spark, so no questions there. Tech trajectory was questionable because by the time we decided to bet on Hive, it was already kind of in a legacy status. And so what that meant is that there wasn't as much momentum behind the technology, and a lot of the companies in the tech ecosystem were transitioning out of Hive. And given that migrations take years, it was kind of apparent to us that by the time we actually finished the migration, we would then end up with a legacy system that we would also need to migrate from. And that definitely was a big challenge. Cost. So a lot of times, the tech choices are driven by whether the system is going to be cheaper, and there is related to that is open source trap, which is a common idea that open source technologies are cheaper because you don't have to pay a vendor and don't have a vendor lock-in. But something to be aware of is the cost of ownership. So in the case of our infrastructure back at Lyft, it did require a lot of resources, pretty much entire team, and the support of third-party vendor just to be able to run this infrastructure, which is quite different from modern warehousing vendors like Snowflake or Databricks. So if you are considering migrating to open source, I would really encourage you to think really carefully about your total cost of ownership. So architecture, I think Drew covered it really well. So you have lift and shift, or you can do things the proper way. And it's really tempting to do things the proper way and to fix some tech debt in the process. And that is something that I actually decided to do in this process. And that was a terrible, terrible mistake because by itself, migration is a complex project. If you try to re-architect things, that just sets the project for failure. And my really big mistake wasn't that I not only wanted to optimize the SQL, which was really ugly, of course, but I also wanted to re-architect the data model itself. So now think about this. You are doing a migration and you have to re-architect your data model. So you have to work with stakeholders to come up with a better one. And that just balloons the costs quite significantly. So if you ask me, I think that lift and shift is probably a really safe default for anyone doing immigration right now. Outsourcing. So one thing that we actually did well was to outsource the migration efforts to a third-party consultant, because especially if you're doing a lift and shift architecture, each migration unit, which could be a table, an Airflow job, can be outsourced to a third-party consulting shop, and you have experienced data engineers who can be tasked with performing a very well-defined task of taking a job which was running on an old system and porting it to a new system. And you can pretty much scale this process by just hiring more consultants, having more hands and heads working on the problem. And it also protects your internal team from having to do migration, because typically that is there's a huge opportunity cost for your team to work on this because they're not working on advancing the business forward. So one thing that you shouldn't do, which I of course have done, is to task your consultants with coming up with better code and better data models. So that is absolutely no-go, because someone coming in from outside of your business, not having context on your domain, definitely cannot do this in a reasonable amount of time. So sequencing. So this is one that is interesting, which I don't think we covered in depth today, which is how do you sequence your migration? And there could be a few patterns. The pattern that I found most powerful when working with different companies was actually to first just set up a copy of your derived data, so the data which is used by the business from your legacy system to your new system, so that you can switch the business consumption, so BI tools like Looker and Mode and other stakeholder-facing applications, to consume the data from the new system. And even though this data is actually produced by a legacy warehouse or legacy orchestrator, what this does is actually hides the complexity of the migration from the business, gets buy-in from your stakeholders to use the new system, and allows you to really do whatever you want in terms of the migration of your derived data. So that is separation of complexity really, really helps. And the last thing I'll say is probably automation. So a few speakers today talked about how they automated various parts of the migration process, and I'll just do a super quick recap. So at the planning phase, especially if you have a really mature data platform with lots of dependencies, column level lineage can be a really powerful tool that allows you to build the map of your dependencies in the data platform. So it can help you understand the dependencies, and that what that allows you to do is to, one, figure out what things you may not even need to migrate if they're not used, and two, figure out the proper sequencing. So what jobs should be migrated first, what jobs should be migrated last, and overall have a much better control over the entire process. So If you're interested, this is a capability that is provided by multiple vendors, including data observability folks. This is also something that we offer at Datafold. The other important thing is query translation. So for example, if using GCP, they have a query transpiler that can be used to port SQL between different dialects, for example, from like Teradata to BigQuery. If you are not migrating to GCP, there is an open source package called SQL Glot that has a Python interface and can also help you translate between dialects. And then also definitely you should check out the Faire's translation layer that I hope Rafay will share us. And the last thing is validation. So again, was covered today by a few talks, but the big importance of validation is if you're doing lift and shift, and in general, to make migration a success, you have to convince your business that your new data is as good as your old data. And that is not an easy task because a lot of the times there will be discrepancies because you're translating dialects and you are changing the warehouses. And so the tool that you can use to make sure that you internally know that your data matches and also prove to stakeholders is called data diff. So data diff is like git diff, but for data, helps you do comparisons. And it is available as an open source package, as well as a cloud tool that Datafold provides. So you can start using data diff today. I'll share the GitHub link at the end of my talk. But basically the ways you can leverage data diff, again, like was shared today, was when you are comparing your legacy data or derived data in your new system. So that's the pattern that Faire team used. Or you can also use it to make sure that when you are copying data between systems from your legacy to new, you actually don't end up with any data loss. So data diff can be used to do both cross-database and in-database validation. And that's it. So hopefully my hard lessons learned will help you not make any mistakes. And it's really also inspiring to see a lot of success stories from other speakers today. So if you'd like to give Datafold and DataDiff a try, this is the open source package. It has both the CLI and Python APIs, and it has a lot of built-in connectors, including to a lot of legacy systems. So let us know if you want to give it a try and if you run into any issues. Thank you. So hopefully that was a good summary overview of a lot of lessons learned. And now I would like to transition us to the panel. So speakers, please don't forget to unmute yourself if you are speaking. So given our topic today, I think unlike other data quality meetups where we delve a lot in the philosophy of data teams' work, I think migration is a really practical topic. So my questions today will be quite pragmatic and related to some of the particular aspects of the migration process. So first, what I heard from different teams is that although everyone follows the same sequence steps to actually execute the migration, the challenges are sometimes different and they're really contextual on the business and the problem that they're trying to solve within the migration. So I'm curious, in your experience, what did you find as the most costly and the most problematic step during your migration process?
I would say it's explaining why there's $5 missing on May 15th to the CEO. Like it takes, like, plan on spending an entire month diving into like the minutia like that. It just it derails it can derail everything. And again, that's where something like data diff like allows you to just get ahead of the problem altogether. And you can come to the table out of the gate saying, here is our here's the transparency of all the differences. And we've already done the work on explaining why those differences are, be it perhaps a different way of calculating. Man, they know it's got to be 100%. It's like, sorry.
Yeah, I think there's an interesting question with testing, which I found to be the most costly part, is like, okay, you actually do the migration, but then testing that it's working in the way that you expect. And And what's hard is like knowing what's good enough. I think that especially data engineers, like we want perfect, like we want things to match perfectly, but in many migrations, you might not even be able to, like, a lot of time and cost into trying to get those like last 2 to 3 decimal points of perfection, and probably is not worth the ROI on that additional work.
Yeah, can I expand on that a little bit? So like it resonates exactly, like data validation has been one of the biggest pain during the migration. And what we ended up doing was that we ended up like setting up a metric that, hey, like, all tables need to be up to like 97% parity, because in some cases 100%. So it can be multiple reasons. Like one of the things is like, cadence, right? And it's not just about your data orchestration or orchestrator cadence. It can be some sort of like query buildup, X number of rows that were not there, which is causing this 2-3% discrepancy. So that's where like we establish a baseline metric to mitigate this problem.
From my point of view, I would also say like having that, like during the migration phase, having these two systems running in parallel, that also adds to the overall complexity and costs. Working on two different platforms, keeping two in sync all the time. So you spend a lot of time also in maintenance of the old system while we are migrating to the new one.
Got it. So basically, it sounds like. Sorry, go ahead.
Well, I was just going to add on to that. It's so true. If you have, like, if you're planning on doing a 6 to 8 month migration, that presumably doesn't mean you've stopped all development on your BI stack. So how are you going to parallelize changes, new features, bug fixes, things like that? That adds a lot of complexity.
Yeah, it's interesting that it sounds like the common theme here is that the major lift is actually not in the like technical aspects of migration as kind of replicating data or translating SQL or actually doing the work, but rather making sure that the work you're doing is kind of approved by the business, which kind of leads me to the next question, which is what have you found as successful and maybe not successful patterns or in general lessons learned when managing the stakeholders' expectations? Like, have you actually promised that the data will be matching? How have you set expectations about the timeline of migration, which actually is like a double-edged sword, because on the one hand, the business wants you to migrate faster, but on the other hand, you have to give people a lot of time to switch over, and a lot of your stakeholders don't want to do that. So just curious if you have, like, what are your main takeaways in terms of the stakeholder management in this process?
One that I can jump in with is like the impact of storytelling. So I think a lot of stakeholders don't understand data engineering, and I shouldn't expect them to. Like if you're a product manager or an operations manager, like you don't understand what data engineering actually is. And so sitting down with stakeholders early in the process and being like, hey, when we say data migration, here's what's actually happening behind the scenes, so that they don't feel like it's just magic and it's super easy, which I think is often the case. It's like, okay, we're migrating this data source. It's like, great, that's, how hard could that be? So I think really telling stories and painting examples of like, hey, when we migrate, this table to the new platform, here are all the steps involved, not at a super high level of detail technically, but just like having them understand the complexity, I think can build a lot of empathy so that they don't get frustrated with things taking a long time. And also your data engineers feel like they have the breathing room to actually do things the right way and not have to cut corners, I think is a big part of it. So yeah, sitting down early and telling the story, trying to build some empathy for what data engineers actually do.
Yeah, I think adding on to that, I think it's a lot about also, building a trust across the different teams, that showing them how we are progressing, what's the roadmap, and how we are getting to that, and as well as also delivering incrementally. So, you can showcase that, okay, this is what we did so far, and here are the results, and this is our next step where we go. These are the next steps that we take, and this is the outcome of that. So also prioritizing what needs to be delivered first, and with that, showcasing your result as a way to build trust.
Find find like a champion in your stakeholders, someone who is, has a degree of authority in the organization, who can really champion the work that you're doing. It provides that sort of the extra lift when things, in the middle of a migration project is when things look pretty like it's hard. Everyone's like, so, what have you done? Like, I don't see anything. And you don't deliver until they're actually making decisions. So when they're actually making decisions on the dashboards, that's when the value of what you're doing is actually realized by the company. So having that champion really can help you get over that hurdle and also get really early eyes on making sure you're doing the right thing.
Yeah, champions are everything, I think, in general when they're dealing with the stakeholders. Awesome. Another aspect that I'm pretty opinionated about, but I'm also curious how you're all thinking about is migration something that you have outsourced to seek out outside help from, let's say, a system integrator or consultancy? Is it something that you decided to do internally, and why? And would you change that decision kind of looking back at your project?
I'm biased.
Yeah, we kind of know Drew's answer.
For me personally, I think you also explained a lot, Gleb, during your presentation, like what are the pros and cons, and it's all about weighing the pros and cons, like what should be the best approach in your case. But I think what where it could really help is to provide you the expertise knowledge in doing the migrations. Extra outsourcing would help, but again, the outsourcing teams would not have as much experience and expertise about your business use cases and about your data. So doing the data transformations, if you want to do that, then it will be more more of a use case for your internal teams. But yeah, I think just a bulk migration would be more suitable for an outsourcing team, I would say.
I think I feel like it can be a hybrid model. For example, like in our case, we were talking to some vendors, like we were talking to Datafold folks on how to do data quality and what can be done. Like we were like tweaking so many gears over there. Like for example, like how do you dump data from Redshift to Snowflake so that you have tables in the same warehouse, and then you can run the tooling on top of that. So you're sort of like consulting some other vendors on that. But I feel like during the entire migration, we ended up partnering with so many teams internally, and we had to build relationships just to understand that, like, hey, like I'm a data engineer, I am technical, like I can solve the technical problems, but the core logic that you have in your ETL, whether it's like finance ETLs or product ETLs, that is something you own, and I need to understand, like, or you need to tell me what you're trying to do here in that, let's say, new warehouse. And that's where I feel like, just like, giving that work to like, or outsourcing that work, I feel like it might actually delay timelines further, especially if you have like very complex business use cases. And in a lot of like organizations, sometimes it's not very, the ETL ownership is not very clearly defined. So you actually don't know who to talk to, or like if you are touching that with clause in the SQL, like who is the owner of that?
Yeah, and like in a way, you're acting as an internal consultant in that way. You're going to this, you're trying to extract the correct business rules and then apply that. Where I would say that bringing in an outside agency is beneficial is if you feel you don't have those skills internally to do that kind of work in order to really try to engage and extract that information, because otherwise you're probably going to end up with the wrong thing without taking that kind of mindset.
Yeah, I might be biased. in the opposite way to Drew. Like I've seen so many vendor relationships go horribly sour. And so I think like a few things to think about. One is that like not all vendors are created equal. So I think it's very easy for a vendor to be like, we're going to migrate you to DBT. It's going to take 3 weeks. It's perfect. And like the marketing is not always the reality. So I would just recommend if you go with a vendor to really like back channel, ask other folks in data or other leaders or teams if they've worked with them, and make sure that those references are strong. I think another thing is like pricing. It can sometimes be cheaper, but it can sometimes be way more expensive. So thinking about, are you paying per project or are you paying for time? Because then there's like an incentive to make it take longer so that they get paid more. So like be careful with some of that sneaky stuff. And then also I think some vendors require a lot of like management and project management, and others are pretty like plug and play. And so just thinking about sometimes the time that you would have invested in the migration, you then end up investing in like managing this vendor. So thinking about making sure you have like the project management resources internally to put towards making that vendor relationship successful.
I agree with all those points.
Yeah, very, very, very interesting points. Thank you all for sharing. So my last question, probably to conclude our panel today, is having done a migration, successful, partially successful, and having learned everything, what is your attitude towards that? Like, shouldn't have done it, never again, or hell yes, we learned a lot and we can do another one easily.
I'll say that they're my least favorite projects, but from a business perspective, I think they're vital. Like, if you are at the point where you're seriously considering and you have approval for budget to do this, there's a large business value, and more often than not, there's almost like a ticking clock. I had a client who had a Postgres backed analytic database, and their daily transformations were 23 hours. They were almost at 24, and as soon as you hit 24, it's like the whole system fails because you never catch up. And so quite often there's a clock ticking, because the platform you have, if you don't take action, will basically fail. And so you have to do something about it. And so it's kind of a necessity, I think.
I think a lot of the migrations I've done, I feel were necessary for scale. I think one maybe like regret is often with tooling migrations, like data tooling migrations. So for example, we moved our notebooking infrastructure very early on at Patreon from Jupyter to Zeppelin, and then from Zeppelin to Databricks. And we migrated to Databricks like a little early. And sometimes that can be really hard to suss out with new technologies, is like how early or late you are in their life cycle. Like I think, Gleb, you were talking about how Hive was like kind of legacy by the time you were there. And that's very hard to have accurate judgment on. And we like didn't get a lot of the gains from Databricks early on because their notebooking was just so poor at the time. And now their platform's amazing. It's like way better. You know, the team is very happy long term. But the like initial cost of that and the lack of improvements in like quality of life for the data scientist wasn't worth the pain of migrating. So I think that's one I regret, and I think good lessons learned around of really trying to assess how early you are in a tool or like new technologies life cycle, because if the value is not there, you may regret the cost and the time that it took to migrate.
Yeah, that's definitely very true, and a great point. Probably also can back channel with a lot of teams if you're thinking about adopting a certain technology. Although opinions matter, opinions differ a lot, and I think even for Databricks, at the time there would have a lot of teams who would be like really happy. So it's like super contextual. Rafay, Saurav, your reflections on the migration projects.
I think like I would not say I would never do one again. Like I think like like we are on Snowflake right now, like who knows, like, when we outgrow this tool as well in the future. So it's hard to say that, but if I were to do it again, like I would focus a lot more on data infra org setting are actually non-technical, and non-technical in the sense that not everyone might be comfortable writing airflow operators or like encapsulating or working with a local airflow setup, right? They might just be like, be able to like work with SQL and not more than that. So you need to like learn to empathize with that, because then if you build tooling with this mindset, then you build tooling that like, no one needs to know how to write like Python code to make this migration work. So I would prioritize and focus more on that. We did that, but I would want to do it better. And the other thing is to be able to identify more concrete ownership on who owns this piece of ETL and get an early sign off. The thing is that, like for us, it took somewhere around 10 months for the entire migration. And like we had some sort of like OKR alignment during the quarter for different teams who own their own ETLs. But if I were to do it again, like I would define it in a more concrete sense in terms of ownership and sign off that, hey, like this would be the target for your ETLs to be completed and move to Snowflake. And you can then scope the partnership with our teams on this and like seek help on just like doing the core migration. That's my thought.
For me, I think, yeah, I mean, I also completely agree that it's definitely a necessity. And one of the biggest pain was that because the previous system was developed, let's say 5 years or 10 years in the past, and there were not many people who still had knowledge of some of the domains, right? And then at this point, the new people did not know what to do of this data. Like, what does this mean? Or how do I transform the data? So that has been one of the pain points. So next time, maybe if we had the chance, then it would be very important, very critical to define this ownership at the very beginning, to segregate everything and understand what each section, each domain means, and then start diving into the migration.
Awesome. Thank you all for sharing the stories and reflections. I think there's definitely a lot to learn from, and I feel in general, kind of the data engineering analytics work is a lot of times opaque and underappreciated, and not really, as much talked about. And in particular, the topic of migrations, I felt like has been a gap where a lot of teams that I've talked to, and certainly in my experience, there just hasn't been a lot of insights readily available to learn from. And I hope that what was shared today, and after we share this and publish this more widely, will be helpful to a lot of practitioners. And there's definitely a lot of great lessons to take away from here. So thank you so much for contributing and joining us today, Maura, Drew, Rafay, Saurav. Also, big thanks to Sarah, who helped put this meetup together and make it happen. So see you all next time, and